Hello friends, good evening. Welcome back to Domain Analytics program being conducted by 360DigiTMG. So we are looking into oil and gas data analytics. Okay. So day one, okay, on the day one, we have started with applications of data analytics. Applications of data analytics in oil and gas industries. So we are going to get the data. Okay, we are going to get the data from oil and gas industries, and we are going to work on this data. So what do we have here? So first we have seen the oil extraction process. So in case of extraction, so from where we are getting this data. So we have to use different drilling methods here. Based on the drilling methods, we are going to extract the crude oil and natural gases. So when it comes to in the same way, we have seen several details regarding market analysis. So when it comes to oil and gas industry, it is the largest sector in the world that contains huge revenue. Okay, so the data could be in the format of economics also. We can get a lot of data in the format of economics also. So what we have to do, we have to analyze this data. Okay, so we have to analyze this data. So what are the different applications we have when we do oil and gas analytics that we have seen? So the data, okay, when we are discussing of the data, we are going to get huge data. Okay, we are going to get huge data and with a huge velocity, okay, high velocity. Okay, so the continuous data, we can expect the continuous data. Okay, we are having these sensors, IoT sensors. We are going to use IoT sensors in logistic process, in case of drilling process, after the drilling process. So there are multiple sensors, different sensors that are going to be used in this course of time. So that data we are going to get each minute. We are going to get some data. So there are several factors that we have noticed. Okay, where we have to where we are getting our data and how we are going to use our data. Okay, so in case of ensuring human safety, right? In case of ensuring human safety, we use oil and gas data analytics. So in case of in case of reducing production cost. Okay, in case of reducing production cost, we are going to use the oil and gas analytics. So in the same way, we are going to use, okay, we are going to use data analytics in oil and gas industries in case of predictive and preventive maintenance. So downtime, we have discussed about downtime. Okay, so to prevent or the downtime, we are going to use this. So in the same way, we have in case of different methods. Okay, while we are doing this process, while we are working on this process of oil and gas analytics, so we have upstream, downstream, and we have midstream processes. Okay, so to process all these methods in case of drilling process, we are going to use this. Okay, different data we are going to get, and we are going to analyze this data. So logistics, okay, logistics also plays an important role. Okay, so for procurement or for transportation of the crude oil or natural gas. Okay, so there are many risk factors that will be involved. Okay, so all these factors should be considered and is very important. In the same way, economics, right? As I have said about economics, there'll be a huge data that is related to economics also. So all this data we have to process. So we have seen that before before processing this and building machine learning model, we have to look into our data. We have to find the trends and patterns in my data. Okay, so we call it as descriptive analytics and descriptive statistics. Okay. So descriptive analytics and descriptive statistics are very important. So what we are going to do here? So in case of descriptive analytics, we are going to use different graphical representations to find the trends and patterns in my data. In case of descriptive statistics, we are going to use different statistical measures to know what is happening in the data. Okay, so we are trying to explore the data. Right? When I'm saying okay, we are trying to explore the data. So we call it as exploratory data analysis. Okay, the whole method we call it as exploratory data analysis. Okay, what we are going to do? We are going to do some pre-processing of data. So when I'm saying of the data could be okay, data could be noisy. There could be some issues with the data. Okay, we have to clean our data. That is very important. We have to clean our data. So today's agenda, day 3, we are going to look into exploratory data analysis and data pre-processing in oil and gas analytics. Okay. So generally when we do the exploratory data analysis, what are the questions that we are going to ask? Okay. So one thing is, what is EDA? What is exploratory data analysis? It refers to critical process of performing initial investigations on data so as to discover the patterns. Okay, we are trying to discover the patterns. We are trying to spot different anomalies. We are trying to test the hypothesis and check assumptions. Okay, with the help of summary statistics and graphical representations. Okay, it is very important. Okay, exploratory data analysis is very important in any domain that we are going to use. So when it comes to EDA, okay, EDA starts by asking some basic questions. So we are trying to know what happened in my data. Okay, when I'm saying descriptive analytics, the question that we ask is what happened in my data? What are the different trends I have in my data? Okay, so based on that, we are going to plan. Okay, so the different questions that we ask are: is there an existing unique record ID? Right? Is there an existing unique record ID that we are going to look into? So in the same way, are fields populated with numbers, dates, or alphanumeric characteristics? So this is very important when we are working on our data. This is very important. So what is the distribution of numeric values? We have to understand data. Okay, first we have to understand data, whether my data is numeric or whether my data is alphanumeric or whether I have dates. If I have dates, are these dates in sequential order? All these factors are very important. So in the same way, what is the distribution of numeric values I have? Okay, that I am going to look into. So how is the distribution? Is it a normal distribution or is there any asymmetrical distribution? Okay, that factor also we are going to look into. How my data is distributed in my, okay, that is very important. So in the same way, we are going to look into categorical data. How many values exist for categorical fields? Is it binomial or it is multinomial? All these factors we are going to look at. So how many fields have been left blank? Right? Are there any missing values? Okay, that is also very important factor that we are going to look into when it comes to EDA. Okay, so we will be trying to find the information. Okay, so the complete information of data. We are going to get what is the variable I have, okay, and I am going to get if how many total number of records I have, okay, total number of records, and I am going to get the data type. What is the particular data type? So we are going to look into the info, okay, information. Okay, so when it comes to description, okay, we have something called as description function in Python. So what we are going to get here? So we are going to look into factors such as mean, okay, so standard deviation, minimum value, maximum value, all these factors are very important when we work on our analysis. So these are different statistical measures. So what is it, 25th quartile? What is the value at 25th quartile, 50th quartile? All these values are very important. So we are going to look into all these factors. Okay, how are multiple data sets related? Okay, is there any correlation between these values? Okay, so we have to understand that we have data. Okay, when we have only one variable, we call it as univariate data. When we have two variables, when we are considering two different variables, we call it as bivariate data. And if I have multiple values, we call it as multivariate data. So if I have univariate data, so when I'm saying that, when I am representing exploratory data analysis, so it deals with both graphical analysis as well as statistical analysis. So in case of graphical analysis, what are we going to do? We are going to use different graphical representations. So why do you use graphical representations? It's an interactive way to understand your data. So we are trying to understand the data. Okay. So univariate analysis on one variable to summarize the variable. Okay. So what we are going to do? So only one variable we are going to take and we are going to work on this data. So bar plot, histogram, box plot, all these comes under univariate analysis because we are going to deal with only one variable. Okay. For example, if I have the data, okay, so in x-axis, I'm going to take gender. Okay, so I am dealing with two values here when it comes to gender. It's male, it's female. So I am going to get the count here, right? This is nothing but a bar plot. In the same way, if I want to know the distribution, okay, if I have marks, okay, 1 to 100 marks I have, and I want to know what is the distribution here. Maybe I'm going to view the intervals as 10, 20, 30, 40, 50, 60, 70, 80. So based on this, I'm going to plot my data. So how many students have got marks between 1 to 10, right? Maybe if there are these many people. So how many people have got marks between 1 to 20, okay, 20 to 30, okay, 30 to 40, right? So I may get some distribution here. How the whole data is distributed, that is something I have to look at. So this is also numeric data and it is histogram, as people know histogram. When it comes to box plot, so in case of box plot, I have a box here and have whisker. Okay. So I am going to calculate, I am going to divide the complete data what I have into different quantiles. We call it as quantiles here. So we have like in the center, I am going to have the median value. Okay. This will be my quantile 2. And here I'll have quantile 3 and quantile. Okay. Now at this point, I am going to, if I take my data to 100, okay, 0 to 100%, okay, here at quantile 1, I am going to have 5%. Quantile 2, I am going to have 50%. Quantile 3, I am going to have 75% of data. Okay. So now what I am going to do, I am going to use the formula that is Q3 minus Q1. I want to find the range. Okay, what is the range here? I want to find the range here. That is known as IQR value. Okay, that is known as IQR value. And using this IQR value, I am going to find the fence. Okay, I'm going to find the fence. Okay, when I'm saying fence here, I am going to have these values at lower end as well as upper end because I'm saying here I am trying to find out if there are any outliers in my data. Okay, if there are any outliers in my data, the outliers could be either at lower end as well as at the upper end. So what I'm trying to do here, I am trying to find if there are any objects in it. So box plot gives me, okay, when I plot the box plot calculates these values and gives me if there are any outliers in it. How does it do? So if I want to find the outliers in lower side, so the formula I have is Q1 minus 1 minus IQR. Okay, 1 minus IQR. Okay, sorry, 1.5 into IQR divided by, okay, so sorry, this is the value we are going to take. Okay, so Q1 minus 1.5 into IQR. So I am going to get the lower fence value. So in same way, I am going to use Q3 plus, okay. Here I am going to use 1.5 as the standard value that we have into IQR value. I am going to get the upper fence. Okay. So if there are any outliers here, okay, so I am going to get a value here. If I get a value something like 3.7, okay, so if there are any values that are less than 3.7, that values will be considered outliers. If there are any values, okay, if I get this value, okay, this value, if I get like 70, if there are any values greater than 70, okay, if there are any values greater than 70, that values will be taken as outliers. So in the same way, we have scatter plot. Okay, when I'm saying bivariate analysis, we are going to take two values. Okay, two different variables here. For example, I have something like sales. Okay, sales in my x-axis. Sorry, x-axis. Okay, and I am taking uh, maybe the temperature. Okay, temperature in y-axis. So what is the relation between these two values? Okay, it depends on the product. When I am taking the product as ice cream, right? So when I'm taking the product as ice cream, what is happening here? Where I am seeing that as the sales are increasing, okay, as the temperature is increasing, the sales are increasing. Okay, there may be some relation between these values. So I am trying to find that relation here. So we are trying to find the relation between two different variables to determine, okay, to ultimately we are trying to find the relationship between these values. So if I have the values in this way, okay. So what is happening here? As my y-axis, okay, as my x-axis values are increasing, my y-axis values are also increasing. Okay, that is what we are trying to find here. Okay, so as these values are increasing here, we are okay. We have x values are increasing, y values are increasing. I am seeing that this is the positive trend. Okay, so here I am saying that this is the positive trend I have. Okay, and as the values are closer to each other in a straight line, this could be said as strong correlation. They have a strong correlation between these values. Okay, so we are trying to find the relationship between two different variables here. So in the same way, what if I have the values? Okay, if my scatter plot is this way, this means that my so here I can see that this is a negative correlation. Okay, it is a negative correlation, but it is a strong and negative correlation. In the same way, we have if I have the values in this way. So what is happening here? So there is no correlation between these two variables. Okay. So that is very important. And we calculate the correlation value by correlation coefficient. Okay, we are going to use the correlation coefficient value, which is represented by R. Okay, so we are going to calculate the correlation coefficient value, and that gives that based on that value, we are going to decide if there is any correlation between these values or these variables. Okay. So this is one important factor, and we are going to use this by we are going to plot this by bivariate analysis. Okay, we are going to use scatter plot for that. In the same way, we have multivariate analysis. Okay, in case of multivariate analysis, we are going to use the pair plot or heat plot. That means heat maps. So here I have the data in x-axis and y-axis, where I am going to have all different variables here. Okay, how many number? Okay, if I have 10 variables, I am going to have all the 10 variables on x-axis. I am going to have the all the 10 variables in y-axis. Now I am going to get some boxes here. Okay, I am going to get some boxes here, and in these boxes, I am going to have some color gradient. Okay, so here we have given that if the value is one, okay, the highest value is one, the lowest value is minus. So based on that, I am going to have all these values. Okay, this is nothing but the correlation value. Okay, here I am going to give some color here. Okay, Based on this color, we are going to recognize which two variables are correlated with each other. Okay. So in this case, what we are doing, we are only taking two different variables, but here we are taking multiple variables and we are trying to compare all these values. So this is nothing but this is something related to graphical analysis. When it comes to statistical analysis, there are four different measures that we have. Okay, business decisions we call them. Okay, first moment business decision is nothing but measures of central tendency. Okay, so in case of measures of central tendency, we are going to use mean, median, and mode. And in case of we have second moment business decision here. We have second moment business decision, okay, where we call it as measures of dispersion. Okay, we are going to take the variance, standard deviation, and range values. We are going to calculate these three different measures to get to the measure of dispersion. In the same way, we have third moment business decision, that is measure of asymmetry. So in case of measure of asymmetry, we are going to look into this skewness. The skewness factor is very important. That means if I have the data, okay, if I have the data, how my data is distributed. Okay, so when I'm saying that, if my data is distributed this way, okay, and my mean, median value, okay, my mean value, median value, and mode value are at the center, and my data is distributed symmetrically on the both sides. I am saying this as normal distribution. Okay. But if I have the data in this way, if my data is distributed this way, or if my data is distributed this way, what is happening here? My data is either on my left side or right side, or so it is not symmetrically distributed. Okay, the data is more concentrated on either right side or left side. So this factor is known as skewness. Okay, so there may be a chance of having outliers. Okay. So how do we find out? So we use the box plot. Okay, we know we have seen what is box plot. So we are going to use the box plot, and based on the box plot, we can have the confirmation data. Okay, we can confirm that there are outliers. In the same way, we have fourth moment business decision. Okay, the measure of peakedness or tailness. Okay, that is we are going to measure here. That is curtains. When it comes to pre-processing, data pre-processing is very important. So in case of pre-processing, we may have different factors. Okay, that we have to consider different factors such as typecasting. Okay, so there may be a chance of we have to convert the data type. Okay, so maybe we have the data in integer format. I want to convert that into float format. So what I have to do? I have to use the technique that is called as typecasting, and I have to do it. So it is the data pre-processing. Okay, we understand the data based on my requirement. If I have to convert my data into another data type, I am going to use typecasting. So in the same way, I may have duplicate values, same values, okay, duplicate values. So in case of duplicate values, nothing we can do. We have to remove these values. Removing is the only technique that we have to use here. So in the same way, we have outliers here. Outliers are nothing but the extreme values. So I may have extreme values in my data. So what I have to do? I have three different techniques here: retain, rectify, and remove. Okay, when I'm saying remove, we use the remove option last. Okay, because we lead to data loss. Okay, that is something we have to look into. So what we are going to do here, we are going to use different techniques here to either retain, rectify, or remove. Okay, so we have some methods like trimming. Okay, when I'm saying trimming, So this helps in removing the outliers. Okay. So when it comes to, we have a method called as insorization. So in this method, we are going to replace the values with the upper limit or lower limit values. So we are going to retain these values. Okay. So based on that. Okay. So we have the next method, that is zero and near zero variance. So what is zero and near zero variance? If I have some data here, okay, if I have some data here, if all these values are same, there is no variation in my data. Okay, so when I calculate the variance value, what I'm going to get here, I'm going to get zero. That means I do not, this particular column will have no influence in my analysis. What I have to do, I have to remove, okay, I have to ignore this column and I have to work on my data. Okay, so that is nothing but zero or near zero variance. So when it comes to discretization, okay, when it comes to discretization, what we are going to do? So I have the continuous data. Now I want to convert this continuous data into discrete data, right? So for example, I have a continuous value in the format of salaries. Okay. Maybe I want to convert this data. Okay. So what I'm going to take a mean value, and the values that are above mean value, that are low, and values that are below mean value are high. I can classify in this type, right? So the final column that I'm going to get, that contains low and high values. Okay? So in this way, I can do the discretization. What about missing value? If I'm saying if I'm speaking of the missing data, there is a chance of having missing values, and these missing values we cannot remove them. So what we are going to replace these missing values either with mean value, median value, or mode value. So what is happening here? In case of in case of numeric data, we are going to use mean and median value. In case of categorical data, we are going to use mode. In the same way, dummy values. Okay, if I have some data in the format of categorical format, or in the form of nominal format or categorical format, but I'm going to convert this data to numerical format. Okay, I have two different methods here. One method is one hot encoding or get dummies. Okay, or one more method I have is label encoding. What happens here in case of label encoding? Uh, we have some data, okay, and that is the ordinal data. There is some ordinal data. Okay, so what I'm going to do, I am going to label these particular categories I have in ordinal format, that is 0, 1, 2, 3, right? So based on this order, okay, each and every category I have in the column, that will be converted into these different labels. Okay, so in the same column, I am going to make these changes in the same column, and wherever that value is there, that will be converted into these different labels. But in case of one hot encoding, when we have data, okay, in nominal format, where I do not have any importance of the order here. So what I'm going to do here, I am going to use one hot encoding here. And in case of one hot encoding, different columns will be created. Okay, with the number of variables and number of classes I have here. Okay, so maybe like blue, green, red, yellow, something like that. If I have that value, then it will be represented as one. Or if I do not have value, that will be represented as zero. So it will be created into binary matrix with one and zero values. So this is nothing but the dummy variable creation. So in the same way, we have transformation. So these are called as to normalize data. When I have some data, if I have to do normalization, I am going to use different techniques like log transformation, exponential transformation, and square root, etc. Okay. So we have standardization methods also. Why do you use standardization? Because when I have some data here, okay, when I have some data, I may have this data, I may have different types of values. Okay, so here maybe I am speaking about weight. Here I may be speaking about height. In this case, maybe I am speaking about money, right? So all these factors are involved. When all these factors are involved, different scaling will be there. So in this case, I am going to use two different techniques here: normalization and standardization. In case of normalization, what I am going to do, I am going to take the value, okay, minus, okay, whatever the variable, okay, in this particular variable, I am going to have different values here. So I am going to take each and every value in the data, and I am going to calculate the normalization value. So x minimum by x maximum value minus x minimum value. So I am going to get one value. Okay. So this value that I am getting here in the complete, this complete column, I am going to have in the range of 0 to 1 or 1 to minus 1. Okay. So either of this format, this data will be converted. Okay. So when it comes to standardization process, the formula is x minus, okay, x minus mean divided by standard deviation is the formula. Okay. So here what happens, the mean, okay, whatever mean value will be there after conversion, mean will be converted into 0, okay, and the standard deviation will be converted into 0. So these are two different techniques we have, where we are dealing with the scaling of the scaling process. Because if I have a high number, if I have a high number in the data, if I have a lower number in the data, what is happening here? My machine understands only numbers. Okay, so based on this, just replacing these numbers, I am going to get some data. But machine doesn't understand what is the importance of these factors in the data. Maybe this value has more importance when compared to this value. Okay, so to rectify this, we are going to do this standardization or, okay, normalization processes. So when it comes to text processing, okay, when we have text mining, so we have a lot of documentation when it comes to economics, okay, economics or research, oil and gas research processes. So we are going to have a lot of documentation, okay, when we work on the auditing and all. So we can use these text data, it could be converted, and we can work on this data. Okay, we can get very important insights from this data. For example, with the text analytics involves automatically extracting semantic information from archives. The archives could be related to oil and gas department. Okay, they may be related to patients, or they may be related to logistics data. It could be any data. Okay, so we are trying to look into the text document, and there are many tools that were developed for doing text processing, like BERT, Spacey, NLTK, etc. So what are the different techniques we are going to use? The different techniques that we are going to use are tokenization, normalization, and noise removal. So when we speak about tokenization, we divide the whole sentence into different tokens. Okay. So what is happening? Each and every word is a token now. And we have many other methods, okay, to pre-processes. Okay. And then we have to convert this data into numerical format. Then we can do all these different mathematical operations. So what are the different techniques we have, and what are the different data that we have to apply? Okay, that we have to remove in case of text mining. So if you have any HTML tags that we have to remove. Okay, in case of if you have any extra spaces that should be removed, that are not required in the data. Okay, if you have to convert the ascended data into AXI format, that we have to do. we have to expand the contractions. Okay, if there is anything, we have to work on it. So remove special characters, lowercase, or so in case of lowercase, we call it as normalization. Okay, we do normalization, convert all the data into lowercase. Okay. We convert number of words to numeric form. Remove numbers if numbers are not required. I am going to remove them. Remove stop words. Okay, so there will be some connector words, right, on the each. All these are called as connector words. Okay, we are going to remove all these connector words. Then we have many libraries. Okay, many libraries we are going to compare the values. Okay, after doing tokenization, we have different methods like stemming. Okay, we have stemming. We have and it continues with leptization. So all these different techniques we use for pre-processing. So in case of so here we have taken an example of some data. Okay, so if you have a data that contains different attributes such as company, date, year, open, close, oil price, share price. So we are looking into some data that is related to share prices. So when it comes to share prices, we have opening and closing values. So what is the data types we have? First, we start with data cluster. So when it comes to company, it's a nominal data. When it comes to country, it's a nominal data. What about the date here? Okay, when it's a date is a separate format. Date is a separate format we have. Now we have to look into if the date is sequential data. Are we using this particular data in our analysis? Okay, so if we are using it, why we are using it? Is it for forecasting or for any other analysis? Okay, so that we have to consider. So year, which year? Okay, so we have a sequence of years on opening. Okay, it's a continuous data. Closing, it's a continuous data. Oil price, share price, all these are continuous data. So the different questions that we have, are there any extreme observations present in share price, right? Maybe the average when we take a mean value, that is $10,000. But when I look into the data, I may be having something like $3 million. That is exact. That is definitely an extreme value. Why and all we have to do the research again. Okay, why that value came there. Okay, but by keeping that value we cannot. Okay, so we have to do some analysis and we have to convert the data. So that is an extreme value. So what is the question we can ask here by doing linear analysis? So are there any extreme observations present in the share price? Support your answer with a plot. What you are going to do here? I am going to use my bar plot here. Is the variable oil price skewed or not? So I am going to look into skewness factor here. Okay. If I get some value here, and I'm speaking of skewness here, if the data is this, if my whole data is on the right side of my analysis, okay, or right side of my histogram, okay, whatever plot it is. So we are okay here. I am finding all my data. So what is this? If it is on the right side, it is the negative skewness. There is a chance of having the extreme values that may be the smaller values. Okay, that there is a possibility. So we are going to look into all these factors. Is the variable oil price skewed or not? Okay, support your answer with a plot and metric. So what we are going to do? We are going to draw a skewness plot. Okay, so we are going to look into the histogram. If I am going to look into the histogram, I can find where my data is located. Is it a normal distribution, or there is a positive skewness or negative skewness? In the same way, we have multivariate analysis. Okay, does this scatter plot of oil price and share price reveal potential outliers? Right. So I can look into my data. I can look into the multivariate analysis. I can do multivariate analysis here. Okay, which country has the highest number of companies? Right. Maybe, okay, if I am looking into country data, if I am looking into company's data, maybe I can find all these details. Okay. So when it comes to handling non-numeric data, what we have to do, we have to look into dummy variables. So what we are going to do here, create a dummy variable for each category, okay, each category countries. Okay. In the same way, we have normalization. Okay, when it comes to normalization, scaling the data set is needed for making different data points generalized. Okay. In the same way, if it is required, if it is required, I am going to use transformation techniques. Okay, remove this skewness. To remove this skewness, we can use various transformation techniques such as log transformation, square root, cube root. So this is nothing but the EDA and data pre-processing. Okay. So when I find the outliers, what I'm going to do, right? So for this first question, what I have here, if I find that there are extreme observations in my data, okay, so I am going to apply the pre-processing methods. Okay, so retain, rectify, and remove. Okay, I have to use either of these methods and I have to work on it. Okay, so first I have looked into skewness. What I am going to do, I am going to look into the data. I am going to look into the data and I am going to see the box plot. If there are any outliers, I am going to do the outlier treatment. Okay. In the same way, if I am going to get into scatter plot. Is there any relation between oil price and share price? What is happening? If the oil price is increasing, what is happening with my share price? Right? This could give us a fair chance of understanding the relationship between oil price and share price. Okay, so we can find the number of companies. Here I can use a bar plot. Okay, bar plot, and I can see that what about the companies, oil companies in different countries. Okay, maybe in Japan, maybe in Middle East. Middle East there are many companies. In case of India, there are few companies, right? So I am going to look into this data. Okay, so I am going to take these countries in my x-axis and y-axis. I am going to count these values. Okay, so that I can do. In the same way, if I have dummy variables, what I am going to do, I am going to use the two techniques. Okay, so either one hot encoding or label encoding, and I am going to work with the data. Okay? So we know these are the two different methods we have. So in the same way, we use transformation techniques, we use normalization techniques for processing the data. So let us look this in our program. Okay, so I have taken some data here. Okay, you can see. So in uh, this data is something related to the oil prices. Okay, oil prices and oil companies that we have here. Okay, so here we can see that there are different companies. Okay, the price is related to, right. So we have date and oil price here. Okay, we have date and oil price. Now I have a different data here where I got. Let me upload the data. We have the data. Okay. So this is my data. Okay, I'm just running the data now. So we have to upload the data. Okay, we have to upload data. We have to import different packages that we have here. So if there are no, so based on the data, I am going to install some files here. I am going to take my data. Okay, I have my Excel file. Okay, what are the values I have here? So these are the different values I can see. So now I have the data. I am only taking, okay, the now we can see here, right? Here I have data in the format of time and date and time format. That I am trying to convert this data into only date format. So what I'm trying to do here, I am trying to convert this data into date format. So what I'm going to use here, I'm going to use the date, okay, as type. Okay, I'm converting the type here. I'm doing that. This is the already the data type. Okay, date and time format that is already present. That I want to convert into date format. Okay, so I am creating a new. Okay, I am creating a new column. Okay, that is date. Okay, date, and I am taking the all. Okay. So now you can see the conversion. So in the same way, we have different data sets here. Okay, we have taken different data sets here, but I want the data to be in this format. Okay, so I have taken the date. Okay, I have taken the share price. I have taken the oil price here. So I have converted the data. Okay, if you see, so let us look at the data what we have here. Okay, okay, so here we have the data. So if I look into the data, what I have here, I have date, open, high, low, close, and adjacent and volume. Okay. Now I am trying to take only the values that are required. Okay. I am going to take the share price and oil price. Okay. I have taken the share price and oil price. I am trying to combine this data. Okay. I am trying to combine this data. And here we can see that the share price scale, I am doing the scaling for only the share price. Okay, so what I have used here, I have used here scalar is the function. Okay, so here we are working on data based. Okay, so this is nothing but the min max scalar. Right? So I have converted the data and I have appended all these values here. So that you can see here. Now I have used the same data for data analysis. Okay, now I am working on data analysis here. You can see here clearly. Okay, so I have taken date and oil price. Here I am looking into so what is happening with the oil price. Okay, so this is between 2002 and 2018. I have taken this analysis, okay, this graph, where I can clearly see that there is a rise in the oil prices in 2008, okay, and in 2010 there is a complete dip here, right? So these variations that you can find using the graphical representation. So this is nothing but the ED. So in the same way, if I take the share price, okay, in the same timeline, 2002 to 2018, so we can see that there is a high share price in 2017, right? So we are trying to find the relation between these values. In the same way, there are, as I have explained earlier, we can take pair plot. So why we are taking pair plot, I am trying to find the correlation between these values. So in this particular company, what is happening between share price and oil price, right? So what is happening? That we are trying to find out here. Okay, I have taken the share price in my x-axis and oil price in y-axis. So now I am trying to compare these values. So here I have taken two different plots. You can see here we have taken the cluster. Okay, so we are looking at different clusters, right? So this is nothing but the scatter plot. So I have taken this scatter plot as well as I have taken the line plot. So we can do this analysis on different companies. Okay, we have continued this analysis on different companies. So in the same way, we can compare these values. Okay, we have number of plots here. Okay, we have number of plots. Okay, here we are seeing volume plot. Okay, where I am trying to compare these values. Okay, where I am comparing the share price scale. Okay, share price scale. Okay, with the companies, how it is converting. Okay, how the value is converting, that I'm trying to look into. So this is all part of different EDA part. Okay, so what is happening in these years, 2013 to 2017? What are the different changes that are happening here? Okay, in case of oil price and share price, that we are trying to look at. And here, okay, here we are taking the plot that represented so that represents the different companies here. Okay, here we are seeing different companies and the share price, what is happening with the share price. Okay, so here we can see that in PMO there is a straight line that we are seeing. So I these values are uh, normally distributed. Okay, these values are, we can say that there is some correlation between these values. Okay, how this data is distributed, so that we can see. So this is how we can do the data pre-processing. Okay, this is how we do the data pre-processing. In the same way, how we are going to deal with our data. Okay, so what we have seen today, so we have seen the EDA part. Right? So what is EDA? EDA is nothing but exploratory data analysis. EDA is nothing but exploratory data analysis. So here we use the graphical representations and statistical analysis. Okay, in case of graphical representations, we have univariate data, bivariate data, and multivariate data. So in case of statistical analysis, we have different business moments. Okay, we have first business moment. In case of first business moment, we have mean, median, and mode. This is called as measure of central tendency. In case of second business moment, we have variance, standard deviation, and range. Okay, this is nothing but measure of dispersion. Okay, in case of third business moment, what do we have here? We have skewness. Okay, the fourth business characteristics. We are going to look into the distribution of my data. Okay, so these factors help us to process my data and find the trends and patterns in my data. Okay, so that is very important to proceed with data mining. So next we are going to see different machine learning models. But before that, we have to process our data. We have to look into different trends. What is happening with my data? That is very important. Okay, is there any correlation between different values? Okay, if there is there any variance in my data, if there is no variance in particular variable, okay, what is that? It is zero or near zero value. Okay, I'm going to ignore that, right? So we have to pre-process my data pre-processing, that is very important. After data pre-processing, then we are going to proceed to data mining steps. Okay, so tomorrow we are going to look into data mining. Okay, in case of data mining, we are going to start with unsupervised learning. In unsupervised learning, we are going to look into k-means clustering. So we are going to take data use case where we are going to look into different oil companies, okay, data which contains both oil prices and share prices, and we are trying to cluster this data. Okay. So that will be looking tomorrow. Thank you, friends. Thank you for your time. So let us look into the new topic tomorrow at this same time. Yeah. Thank you, friends. Have a great day.